All right, hello, hello. Are y'all ready for our 28 minutes together? Yes. All right. So, how you doing? New video time. I'm working on the board. I think I have my lines up here to show me how much board space I had, but we'll see. All right. So last we were simplifying expressions, right? And I was telling you expressions differ from equations due to the what? There's one main thing, one difference that you're like, oh, that's an expression, that's an equation. The difference is, do you remember? The equal sign. Yeah. So that's what makes the difference between an expression and an equation. And we were working on, like I said, simplified expressions, which pretty much involves combining like terms. All right? That's what simplifying expression is. You're just combining like terms. If they're not like, you can't combine them. If they're like, put them together. And so this is why you needed those rules of integers, you know, positives and negatives and multiplying, and you need to know what distribution was and all that good stuff. Did we ever finish that big problem? The two Z's and the Z's and the Z's? I don't know. You'll let me know, I'm sure, in chat. But I got some of my favorite stuff for you, fractions. So let's do this one. 1/2, what'd I say? Times x plus 3 plus 1/3 times x plus 10. I think that's what it said. If not, it doesn't matter. We're just going to leave it like that, right? Let's see. No, x plus 6. I should have left it as 10. But we'll leave it. We'll put it back at 6. Erase it, write 6. Just for the example purpose. I'm sure it would have made a difference other than the answer we get. But anyway. So when you see these, some of you think, oh, I know. I just distribute. And you are correct. You can just distribute that 1/2. Make sure you distribute it to each term inside the parentheses. So that would be 1/2 times x, and then 1/2 times 3. And then you bring down your sign and do 1/3 times x and 1/3 times 6. So let's go ahead. We know that 1/2 times x. Remember, variables are substitutes for values for numbers, so they have the same rules. Whereas you see x, we know it's x over 1. And then the rules for multiplying fractions are what? Numerator times numerator, denominator times denominator. So 1/2 times x gives us, you can either write 1/2 x, or, let me get this out of your way. You can write 1 times x, which is x over 2, and that is implied that you have 1/2 x. Again, because the 1 is always kind of understood to be there. So you can show it or you cannot show it. Okay? So if you left your fractions, you have 1/2 x plus 3/2, and then you bring down your addition and you do the same thing, 1/3 x plus 6 over 3. Yes, yes, you're correct. Yes, you could reduce that if you wanted to, but I would leave it all in fraction form since you left the fractions, right? I'll put this little arrow here to help y'all see. So then, of course, we're going to combine like terms. The only like terms that we have in this case, this is 1/2 x and this is 1/3 x. So those are like terms because they both have the variable x, and your x is to the first power. And remember, I told you all constants are like terms. So then you would have to come to the side of your paper and remember your rules for fractions, which is going to say 1/2 x plus 1/3 x. you have to find your common denominator. Remember how I did that? 2, 4, 6, 3, 6, 9. I know 6 is my third multiple of 2. And I know 6 is my second multiple of 3. Right? So then I would end up with 3 times 1 and 3 times 2, which is going to give me 3 over 6x plus 2 over 6x, which gives me 5 over 6x, right? And then you have to do the same thing with the 3/2 and the 6/3. But because they're the same denominators, 2's and 3's, you can already guess what the denominator is going to be. So I want you to pay close attention to that, because that's where a lot of your math skill comes from. When you take your time and you're paying attention to what you're doing, you'll notice a lot of repeats. And from that, 3 over 2 plus 6 over 3, we already know what's 6, 3 over 3 times 2 over 2, giving us 9 over 6 plus 12 over 6, right? So we can rewrite our new equation that we have now as, expression. There's no equals, so our new expression, did y'all catch that? Better be paying attention. 5 over 6x plus, what do we have? What's 9 and 12? 21. Is that 21? Over 6. That is your simplified expression. Improper fractions are fine unless you can reduce them. Is 21 over 6 reducible? Do they have a common factor? You can say from your smile, yes, you are correct, right? Because we could rewrite 21 as 7 times 3, and we could write 6 as 2 times 3. Both of these 3's reducing out. So we could change that to 7 over 2. You're like, what? What? I gotta play this again. Play it again. Go ahead. All we did is we simplified this expression, but we kept our fractions. So we distributed the 1/2 and we distributed the 1/3 when we did it. So now I'm going to keep the same expression and I'm going to do it a different way. Remember I told you there's always more than one way to do stuff. And so you probably want to get good at eliminating your fractions, because that's just a little bit easier. And it's good practice for your brain, get your brain going when you're doing math. And I always recommend that you do things like that, like go to the side and show your work, take your time and do these little steps, because it's gonna stay right there. It's gonna help you. So I'm gonna erase this part. You got this, right? I'll just erase this, because we already know what our common denominator is, right? What's our common denominator between 2 and 3? 6. So we're going to do it a little bit differently this time, okay? We're still going to distribute and everything, but like I said, we're just going to get rid of the fractions first. We decided we don't want fractions. We're not going to do fractions. I love fractions, but I know a lot of you don't like fractions. So I'm going to show you how to get rid of your fractions. So again, these are the fractions part. Please recognize that this is one whole term. If x had a value, let's just say the value was 1, and we would have 1 plus 3, which would be 4, and then 1/2 of 4, which we know is 2. So we treat this as one whole term, just like any other variable term. Just because we have to distribute this to each pieces of the number on the inside, kind of think of it like a part of a number. We just don't know what number yet or what value yet, because we don't know what x is. Is x negative? Is x positive? Is it some funky number within itself? Like, x could be anything, right? So this is a multiplication, that rule for multiplication that says 4 times 5 times 9 is the same as 9 times 4 times 5 is the same as 5 times 9 times 4, however you want to do it with the multiplication, okay? That's those little rules. So this time, we're gonna do it, we're gonna get rid of our fractions. And we decide, or we determine that 6 is our common denominator. So we're gonna multiply the entire expression. That means every single term, right? But what I tell you, this is one term, and this is one term. So technically, we only have 2 terms. This mathematical operation separates that. This is one term plus another term. We only have 2 terms. We found our common denominator between 2 and 3 to be 6. We don't want to do fractions. So we're going to get rid of the fraction by multiplying by the common denominator. Again, is if we multiply it by 6 over 1, then we can take these rules, right? We can reduce ahead of time. Because I know that 2 is a factor of 6, and it goes into 6 3 times. 2 goes into 2 once, 2 goes into 6 3 times. And the same thing over here with this 3, right? Because this is the fraction in front of this term. 3 goes into 3 1 time, and 3 goes into 6 2 times. 3 over 1 is the whole number 3, right? And 2 over 1 is the whole number 2. So now we have 3 times x plus 3 plus 2 times x plus 6. Okay? Giving us 3x plus 9 plus 2x plus 12. Do you recognize these values? Do you recognize these values? Now we add our like terms. This one, 2 variable terms, right? Those are our like terms. Our constant value, like terms, 5x plus 21. And because we got rid of that denominator, we got rid of our fraction, our common denominator is 6. So that's why in our first answer that had the fractions, notice we had the same value, but it was over 6. Both answers are correct. It depends on the concept that your instructor is teaching at the time. If they want you to get rid of fractions, then this is what you need. If they're just working on distribution and simplifying expressions and combining like terms, the first answer should be fine. Okay? You will always be directed to each. Let's try another one. You ready? And how do you want it? With fractions or without fractions? How do you want it? We'll see. We'll see what the problem says. Okay. We good? I'm going to take this one down. Let you pause and go back if you need to see anything. Right? Okay. Let's do another one. Okay. All right. So, I thought I saw something nice. Yeah, here's one I like in here. I don't know if you can see this one. Let's see. We have 3 times 1 over 3x minus 2x plus 1 over 6. Is there X on that? Nope. Cool. That's a cool one, right? Recognize that 3 is in whole number form. So let me rewrite that for you so you can see it better. Because it's times everything in the parentheses. So that 3 is in whole number form. So that does mean we're going to be 3 times 1/3, 3 times -2, and 3 times 1/6. In this situation, I'm like, okay, if I do want to get rid of the fraction, it's cool because once I distribute to the 3, that 3 to everything in here, they reduce out, right? Because 3 times 1/3 just means 3 over 1 times 1 over 3x. And then we have, we're going to say, because that's a positive 3 times -2x. We're going to say plus 3 times 1 over 6. So parentheses and the dot represent the same thing. So to be consistent, I'll take this dot off and put parentheses there. Okay, so I told you the parentheses have a lot of job. They're grouping symbols. They also represent multiplication. So when I do this, same way before, because rules never, ever, ever change. And we can still put this over 1 if you want. We can put it over 1 with the fraction here. It doesn't matter. We know that these 3's will reduce out. These will multiply straight across. That becomes 1, and that becomes a 2. Right? So 1 times 1 and 1 times 1, x minus 6x, a positive times a negative. Remember, positive times a negative, negative times a positive. Tic-tac-toe, diagonal pluses. The rest minuses. Right? Positive times a negative, and then plus 1/2. This has an x, this has an x. That makes these like terms. What number is understood to be in front of this? The understood 1. And when you're adding and subtracting integers, if you start with $1 and then you go spend 6, you are in the hole $5. Your final simplified answer, negative 5x plus 1/2. Yeah. Not bad, right? Like, I can do this. Of course you can do this. Of course. Don't let the way things look intimidate you. Okay? I'll say it every day. Do not let the way these numbers and these values look intimidate you. Rules do not change, and that's the cool thing. Rules don't ever change, so it doesn't matter what it looks like. As long as you know the rule, you got this. Check it out. We'll do one more that I think look kind of funky. How about 44x times 1/11? Is that challenging enough for you? No? Because 11 is a factor of 44. 11 goes into 11 one time. 11 goes into 44 4 times. Not challenging enough? Okay. Touche, touche. I got you. Let's try something else. That was easy. I hear it. I can hear it all through the little camera. Let's see, how about, ooh, this might throw you off. Negative 3/4 times negative 8x plus, ooh, open parentheses, negative 3x plus 5 times 5. Ooh, now what do? Ooh, it's so different. Don't even fall for it. Remember multiplication? It don't matter if that 5 is over here or if that 5 is over here. You're still gonna distribute to it, so it don't matter, right? Rules don't change. We know this 8 has a denominator of 1. That puts this 3/4 times 8/1. Right, that ain't nothing. You got this, don't you? Go ahead, get started. I'm gonna let you get started. Draw my little tic-tac. Oh, it's already up there. Let me see here. Negative times a negative is a positive. That's great. And a negative times a positive. Cool. Just want to make sure. You know what I'm saying? Just want to make sure. You got it? You already done? You waiting on me? All right. 4 goes into 4 once. 4 goes into 8 2 times. Negative times a negative is a positive, so negative 3 times negative 2x is a positive 6x. I'm going to go ahead and distribute this way like I'm supposed to. Positive 5 times negative 3, negative 15x. Positive 5 times positive 5, plus 25. And then my signs are different. So I will subtract my values because now I'm not multiplying. I am adding and subtracting, which is the same thing as combining terms. When I combine, I'm putting them together. And so I will subtract these two. 15 minus 6 is 9. The 15 is negative, so the 9 is negative plus 25. Is that what you got? Good job. Good job. Good job. Wait till we get to factoring. All right, so I'm gonna put a word problem up here for you. I don't like doing a lot of writing, and I was like, how am I gonna go over word problems with them? Because there's so many words that represent the mathematical operations. So many words. But I figured I'd just throw the word problem up and we'll talk about it. And I'll put words up there slowly. Maybe next time when I start the video, we'll have a whole bunch of words on one board or something. Okay? We'll do it like that. Let's see. So for right now, let me put one of my favorite word problems up because I like this one. I like the word. It says, for 2 consecutive, that's the key word right there, consecutive integers. Ooh, what's my time, you guys? I don't know what it is. So the sum, you know, this video only has like 28 minutes. The sum of the smaller, for 2, the sum of the smaller and twice the larger, and twice the larger. So notice it doesn't give you any operations. It doesn't say was split or was shared or was distributed or whatever, you know, and those are the words you're looking for. But because it doesn't say lead to or left over or remained or anything like that, those particular words, which would imply an equals sign, and none of those words are here. So that's how you know that this is just a written expression. Okay, so let's talk about, let me do something easy. Anytime you have word problems, I always suggest that you write it down and take the word out. We know sum means addition, right? So we're gonna add something. And then we read it and we're like, we're comparing something. We're comparing 2 consecutive integers, right? The sum of the smaller and twice the larger. Well, we know twice means 2 times, right? 2 times. So whatever the larger number is, it's going to be 2 times that. So we see that we're adding a smaller value and twice the larger, but we just have to figure out what it means for 2 consecutive integers. So again, I told you the key word was consecutive. What does consecutive mean? What does it mean if something is consecutive? Let me see. Let me see what Google says about it. I know what it means. It means in order, back to back, one after another. Consecutive.
Here's the definition of consecutive. Following continuously.
That's cool. Following continuously in unbroken or logical sequence. I like that, in sequence. In order. Consecutive means in order. It means back to back. So if you count consecutively, you're like 1, 2, 3, 4, 5, right? If you were to name the days of the week consecutively, it'd be Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday, or whichever day you start with. If you were to name the months consecutively, depending on where you start, July, August, September, so it's in order. So we're looking for 2 consecutive integers, 2 numbers that are in order, right? So it'll be 3 or 4, 5 and 6, 24 and 25, -11, and -12. We don't know. It's just 2 values. So we're going to figure it out, right? And so what do we do when we're talking about a value we don't know? What's that called? Do we remember? Remember that vocabulary I was giving you? And for values, for unknown values, we let it be a variable, right? So we're going to call the smaller number, because that's what we're comparing, the smaller, and I'm gonna do this for number if that's cool, okay? I want to say the smaller number, let the smaller number be, what do you want, A? Okay? And then we can put it equals there because they're the same. That means the bigger number will be B, right? So we can come back up here and we're gonna say if smaller is A and twice the larger, we know that that means B, right? So for two consecutive integers, the sum of the smaller and twice the larger. So now we know that we have the sum of the smaller and twice the larger. Dun dun dun! Look at that, you did a word problem. Yay! Yeah? Make sense? Okay. Or, you know what? Now that I'm thinking, don't hate me. This might be a little advanced. What makes it advanced, you say? Because you have two different variables. Let's go back to the word consecutive, right? And we said they were back to back. So let's just say the first number was 4. The next number is what? Right, 5. So when we go from 4 to 5, what's happening? How do we get from 4 to 5? How do we get there? Because we had 4, and then the next value was 5. How do we get there? We had 4. What did we do to our 4 to give us 5? We added 1. Okay, that's right. That gave us 5. So what if our first number was 20? What would the next number be? If we're counting consecutively, the next number would be 21. You're correct. And so how do we get from 20 to 21? Perfect. So that means that any number we started with, because I'm thinking, like I said, they don't want you to have two variables yet. I just think it's early. It's early. So how would we represent this with just one variable, right? How do we do this with just one variable? If the smaller number is A, like we said, we're not going to let this be B anymore. How do we get from one number to the next? So that means this could be 2 times, I'm going to change that to A plus 1, right? Because whatever it is, if the smaller number is A and we're consecutive, then whatever it is, all we have to do is add 1 to get to the next one. So then in reality, our equation would be our expression. I know I'm not on it today. As you heard, my phone's been going off. It's just a lot going on. I'm like, I'll go make a video, take my mind off stuff. So, twice. There you go. Right? And then, of course, you would have to simplify that. And that would be making your final answer make more sense? That's how you do it with one variable.